All right, now here's a storyboard that touches upon the electrolytic properties of solutions with your product.
Dry cells like carbon, zinc, or alkaline batteries are fine for toys or radios, but when you need real power, there's only one way to go. The wet cell is best. A strong electrolyte in hydrogen hydroxide gives me the power I need.
Hydrogen hydroxide. For real power.
Some substances readily conduct electricity, and some don't. Metals conduct electricity. Rubber does not.
That's probably why the metal is on the inside and the rubber's on the outside.
People conduct electricity too. Let me show you. I need you to hold the positive lead of this meter while I hold the negative lead. Now, let's hold hands. But don't get any wrong ideas here. This is just science.
Hey, we're conducting electricity.
Not enough to light a bulb, but enough to register on this meter. A salt solution conducts while a sugar solution does not. Salt is an electrolyte and sugar is a non-electrolyte.
Ionic compounds that dissolve in water form electrolytic solutions. Covalent compounds are generally non-electrolytes. Aqueous solutions of acids, bases, and salts are examples of electrolytic solutions. Look at the difference between electrolytes and non-electrolytes at a molecular level.
Sugar is a covalent compound. When it is placed in water, the sugar molecules break away from the crystal and are surrounded by water molecules. But the sugar molecules themselves remain intact. Sodium chloride is an ionic compound. When salt is placed in water, the sodium and chloride ions actually separate, or dissociate. Both sugar and salt dissolve completely in water, but only salt dissociates. Hydrogen chloride is a covalent compound, but it forms an electrolytic solution. When placed in water, hydrogen transfers its electron to the chlorine atom, forming ions, and the ions dissociate. While all electrolytic solutions conduct electricity, there are variations in the degree to which they conduct.
The degree of conductivity is affected by the degree of dissociation. Some compounds, like acetic acid, dissolve in water but only partially dissociate. How does the conductivity of a solution relate to dissociation of the solute?
Now examine another factor that affects electrical conductivity. Sodium sulfate and calcium sulfate are both ionic compounds, so we know they will tend to dissociate in water. When placed in water, sodium sulfate dissolves completely. Calcium sulfate hardly dissolves at all. The solution containing the ionic compound that dissolves more is a better conductor.
Electrolytic solutions conduct electricity because the charged particles are free to move toward oppositely charged electrodes. What determines the degree of electrical conductivity of a solution? The number of ions present in solution determines the degree of electrical conductivity, and the number of ions present is affected by both the degree of dissociation and the degree to which a solute dissolves. Limestone does not conduct electricity. I wonder if this solution of limestone in water will conduct electricity. The calcium carbonate in limestone is an ionic compound. It dissociates in water to form an electrolytic solution. The human body is 80% water. Our cells contain many compounds in aqueous solution. Many of these compounds are electrolytes that can cross cell membranes. This movement of electrolytes allows the human body to conduct electricity.